welcome back children. In my previous class of your chemical bonding, we discussed about two kind of chemical bonding. The first kind of bonding is electrovalent bond, or we call them the compound formed by electrovalent bond is called electrovalent compound, or also called ionic compounds, whereas the second one was a covalent bond, or the compound form called covalent compounds. Now the difference between electrovalent and covalent was such that in electrovalent, compounds were formed by transfer of electron, whereas covalent compounds were formed by sharing of electrons. We also saw example of electrovalent and covalent. You saw in both the cases, whether it was electrovalent or covalent, ultimately the atoms or the ions, they were getting the stable configuration of either 8 or 2. In some cases like hydrogen, it was getting 2, which we call as a duplet configuration. So the octet configuration and the duplet configuration is what was being followed whenever the combination between different atoms were taking place to form electrovalent or covalent. And then yes, we had finished half of that chapter till that point. In case if you have missed that video, so I'm going to put that video's link also there down in the description. That first part of this chemical bonding, you can have a look at that. Now moving further, now covalent bond, the one which is formed by sharing of electron, as you saw many examples in the previous class. This is categorized under two heading, covalent bond. One is what is called non-polar covalent compound, and the other one is what is called polar covalent compound. Now what is the difference between polar and non-polar? Now in the first chapter, that is in periodic table chapter, we have learned something called electronegativity. Now what is electronegativity? Electronegativity is the tendency of an atom to attract the shared pair of electron towards itself. Okay, now let's see some example now here. So first I'll explain, then after that I'll tell you what exactly is non-polar and polar. Let's suppose, for example, a hydrogen is combining with another hydrogen. Hydrogen has one electron and another hydrogen also has one electron. Then we saw already this atom, molecule of hydrogen, where how these two atoms are combining. They will share that one electron which they have to give rise to H dash H, like this. This dash which we have written is what we call as the covalent bond. This is the bond, single covalent bond. Now the tendency of an atom to attract the shared pair of electron is what is electronegativity. Now this one is also hydrogen and that is also hydrogen. Now if I ask you, out of the two, which one has a greater electronegativity, then both of them are same, since both of these are atoms of hydrogen. So that means what is the electronegativity of hydrogen? Same is the electronegativity of this hydrogen also. So that means this shared pair of electron, the bond which is there, is neither shifting towards that hydrogen nor it is shifting towards this, because both of them have same electronegativity. The combining atoms are same. Same thing happens with oxygen. In oxygen also, double bond. So double bond between two oxygen. So electronegativity of both oxygen is the same. So that means the double bond is neither shifting towards that oxygen nor it will be shifting towards this. Same thing with nitrogen, triple bond. It is not shifting towards this nitrogen nor that. Or chlorine, if you are talking about chlorine also will be bonded by a single bond. So it is neither shifting that nor this side, because both the chlorine have the same electronegativity. So that means the tendency to attract this shared pair of electron towards that is exactly same as the tendency of this chlorine atom to attract that. So that means this is neither going towards that side, the bond is neither shifting towards that nor it is shifting towards this, because both of them have the same electronegativity. But when the combining atoms are different, you can see all my example, I have taken the combining atoms which are similar. They are similar and they have the same electronegativity. But when the combining atom is different, now let us combine hydrogen with chlorine. Hydrogen have one electron, chlorine have on the outermost shell 7, 2, 3, 4, 5, 6, 7. They will share one pair of electron here like this, and HCl is formed. So here you are, a single covalent bond between the two. Hydrogen is duplet and chlorine is what is 8 octet. Now the combining atoms are not same. Now if you remember in the periodic table, your hydrogen is here, your chlorine is there. As you go from left to right, electronegativity increases, means chlorine has a very high electronegativity as compared to hydrogen. So that means chlorine has very high electronegativity. The meaning, electronegativity means the tendency of an atom to attract the shared pair of electron towards itself. So the tendency of chlorine to attract this shared pair of electron towards itself is much more higher as compared to the hydrogen. So that means this shared pair of electron now is pulled towards that chlorine. Yeah, because chlorine has greater electronegativity. Here now the shared pair of electron has gone towards chlorine. Shared pair of electron means a pair of electron. Now electron density towards chlorine has increased now. Now more electrons are there towards chlorine, and since electron is negatively charged, so that is why this chlorine is automatically developing a slight negative charge, and this slight negative charge is what is we represent as del negative or delta negative. So that means chlorine, even though in covalent compound we say that they are chargeless, they don't have any charge, they don't form ions, they remain as molecule. But polar covalent compound is an exception. You can see in polar covalent compound, because of difference in electronegativity, because of the fact that electron density is increasing towards one atom, the one which has greater electronegativity, that is what will get slightly negative charge. And since electron have moved away from hydrogen, away means now this hydrogen is electron deficit. Deficit means less number of electron, and because of which this is automatically developing a positive charge. So positive charge, negative charge. This kind of charged particle is what we saw in the first compound, that is electrovalent compound. But in covalent compound we said it doesn't have any charge. But you can see a polar covalent compound is a special covalent compound where charges are developed. That is why such kind of compound where charges are developed, even though charges may be very, very slight, but still charges are there. Such kind of compounds, whenever dissolve in water or when they are made molten, they will form ions. So even though later on when we discuss about conductivity, we say covalent compounds are bad conductor of electricity when they are in aqueous solution or in molten state. But polar covalent compound is an exception, because polar covalent compound start conducting electricity because of the development of charges. These compounds, as I said, when you dissolve in water or when you are making molten, they start conducting electricity. For example, HCl will start conducting, and don't forget, here we are talking about conduction of electricity by compounds, chemical compounds, not physics conduction. Physics conduction is your metallic conduction. But compounds will start conducting electricity if they are made up of ions, especially when they are in aqueous solution or in molten state. If they can produce ion, then we say they are conductors. And here polar covalent compounds, when you are dissolving water, for example, if you are dissolving this in water, when water is added to it, this hydrogen will go and join with water to form hydronium and chloride ion. So here chloride ion is formed, and it is all because of the fact that it is polar in nature, polar covalent compound. So ions are formed, and whenever ions are formed, HCl, even though it is a covalent compound, again I am repeating, covalent compound, they don't conduct electricity, but HCl, being a polar covalent compound, when dissolved in water, it will produce ions, and because of the production of ions only, it starts conducting electricity. This is what is your polar and non-polar compound. So that means, how do you understand, sir? Now if you ask me, so how do you understand, sir, which one is polar and which one is non-polar? Easy. If the combining atoms are similar, like this, similar, then we can say that it is non-polar, similar. But if the combining atoms are different, like this, like for example this one, even in case of water is a combination between oxygen and hydrogen. Now let me write for oxygen. Oxygen has 1, 2, 3, 4, 5, 6 electrons in the outermost cell, and hydrogen 1 here and another here. So water molecule here sharing of this, they will share these electrons. Now if you count hydrogen, this hydrogen duplet, that hydrogen is also duplet. If you count oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So that means water molecule is written like this. Yeah. Oxygen having 2 single bond around it, whereas each of the 2 hydrogen is having a single bond around it. So that means this is what is the structure of water. Now please understand, later on when we do structure of hydronium ion, it is very important that this electron of oxygen was used for the formation of covalent bond. That electron of oxygen also was used in the formation of covalent bond. That is why such pair of electron, this pair of electron which are used for the formation of bond is called bonded pair. Bonded. They were used in the formation of bond. Bonded pairs of electron. Bonded pairs. Whereas, as you can see one pair of electron here and the other pair of electron here of oxygen, which were not used for the formation of any bond. Such pairs of electrons are called lone pairs. So lone pair. So bonded pair. Now you will have bonded pairs of electron, lone pair of electrons. Now this lone pair will play a very important role now in the next kind of bonding that we are going to discuss, coordinate bond. Lone pair, it is all about this lone pair. So lone pair will play a role in the formation of the third kind of bonding. After covalent bond, I am going to the third bonding, and that is what is your coordinate bond. Alright, now, so that means if the atoms, combining atoms are similar, it is non-polar. If they are different, like H and Cl, or as you can see, oxygen, hydrogen, or ammonia, nitrogen, hydrogen, they are polar. But there are few exceptions. But for example, one biggest exception is methane. You can do the same thing with the carbon tetrachloride also. Now let me write methane, even though we have seen the structure of methane already in the previous class, structure, covalent compound. Now let us see what happens in methane. We saw a structure of methane, 4 electrons on the outermost shell, so that is why it was forming one bond here, second one here, third one here, and fourth one here. Now the question is, now if you ask me, so methane is what, polar or non-polar? Now I'll say that the combining atoms are different. It is about carbon and hydrogen. So if the combining atoms are different, then it should be polar. Combining atoms are different, so it should be polar. But this is non-polar. So even though the combining atoms are different, you can see it is a non-polar. Now why it is non-polar? Between carbon and hydrogen, now if you compare this carbon and hydrogen, electronegativity of carbon is higher. Again, going to the periodic table, carbon is somewhere here. So as you move from left to right, electronegativity increases. So electronegativity of carbon is higher, means the bonded pair between this carbon and hydrogen is shifting towards left side, towards carbon. But at the same time, the other hydrogen on the other side also the same thing happens. Here, between this carbon and hydrogen, electronegativity of carbon is more. It gets shifted towards that side. Now the shift between the two is what is neutralized with each other. That means what you see on the left and what you see on the right, the pull from both left and right gets nullified, gets neutralized. So that means neither this bond is shifting towards carbon nor this bond is shifting. That means they are not shifting anywhere now. Now if they are not shifting, means there is no development of charges. No charges are developed. Same thing happens with this and this also. If there is a shift from here, there is a shift from that side also. So they nullify each other. They cancel out each other's attraction. They cancel out each other's that formation of that bonding which might have taken place, formation of that small charge which might have taken place. So that is why there will be no shift. And since there will be no shift, no development of charge, so that is why they are non-polar. In fact, methane is non-polar. Same thing, carbon tetrachloride, non-polar. Instead of hydrogen, chlorine will be there on four-sided. So around carbon. So that they are also nullified. So they cancel out each other's effect. So that is why even though the combining atom is different, but still it is non-polar, and it is because of this reason. Now let's go to the third kind of bonding. And that third kind of bonding is called coordinate bond, also called dative bond. Now a coordinate bond is also a type of covalent bond, because here also sharing of electrons will take place, but the sharing of electron which is taking place is something which is little different from covalent bond. Because even though, for example, if X and Y are the two atoms, sharing of electrons will take place, but strangely the sharing will take place in such a way that both the electrons which are used for the formation of the bond is being contributed by one single atom. That means previously in covalent what was happening? X and Y. So how many electrons X is contributing? Same number of electrons Y also is contributing. So it is a mutual contribution, mutual sharing of electron. Mutual means one electron from here, one from there, or two from here or two from there, three or three. So formation of single covalent bond or double covalent bond or triple covalent bond. So mutual sharing. But here there is no mutual. Only one atom is giving the electrons which are required for the formation of bond. So both the electrons belong to X. So that means it is contributing for the formation of the bond between the two. Such kind of bonding is what is called a dative bond or coordinate bond. Again I am repeating, even though it is sharing of electron, but the sharing of electron takes place in such a way that both the electrons which are used for the formation of the bond is being contributed by a single atom. Such kind of bond is called coordinate bond or dative bond. Now you should know that some chemists are of the opinion that coordinate bond is also sometimes called co-ionic bond. Now why co-ionic? Because co means covalent, ionic means electrovalent. So that means coordinate bond is a combination between both kind of bond, covalent also and ionic. Now let me explain to you why, or what this chemists are saying. Suppose if X has 2 electrons and Y doesn't have any. So rather than saying that okay, both of these electrons have been contributed to X, now some scientists believe that first bit when this X and Y combine together to form a molecule, they believe that out of the two electrons in the lone pair, by the way I'll call this as a lone pair of electron not used for formation of any bond. Out of the two electrons in the lone pair, they believe that the first stage, step 1 is one of the electron gets transferred to Y. Now it will be something like this. Previously it had two electrons, now it has only one electron now even Y has one electron. Now since transfer of electron has taken place, so that is why we say it is electrovalent bond. So see, ionic bond has come because transfer of electron has taken place. Now Y also has one electron, X also has one electron. Now since both of them have one electron, now there will be a mutual sharing, formation of covalent bond. So that X dash Y is what is formed. So that means here second one is a covalent bond form. So previously it was ionic because transfer took place. Now there is sharing. So sharing is taking place, that is why covalent. So that means your coordinate bond is a combination between both electrovalent bond and covalent bond. So electrovalent bond transfer, sharing, covalent. So that's why sometimes we also call coordinate bond as co-ionic bond. So in case if you are asked why it is co-ionic, then you have to understand that co-ionic actually means your coordinate bond or your dative bond is a combination between, because first transfer of electron will take place, then after that sharing of electron will take place. Now you will understand this coordinate bond better. Now I think two things I am going to discuss it together now. Coordinate bond, at the same time formation of hydronium ion as well as also ammonium ion. Now what is that hydronium ion and ammonium ion formation? Again I am repeating, coordinate bond, hydronium ion formation and your ammonium ion formation. Let's discuss these three together. Now going on to explain to you this two ion formation. First I should explain to you what is H plus. Okay, hydrogen atom. You know hydrogen atom has one electron. It has only one electron. That one electron also when it is lost, when it is losing that one electron, then hydrogen will become H plus. So that is why this H plus which you are going to see is what is hydrogen without any electron, meaning only proton is there, one proton is present inside the nucleus. That is why H plus is also the representation of proton. So what is the symbol of proton? So you can say symbol of proton is H plus. H is hydrogen atom, but that one electron which is present is also lost, and now only proton which is present inside the nucleus is only present. So that's why when I write H plus, don't forget there is no electron, only proton is present. Okay, why have I written that? Now you will understand better. When ammonia combines with proton H plus or hydrogen ion, it will give rise to ammonium ion. Okay, now let me explain to you how ammonium ion is formed, which is also a part of your syllabus, a very important part for your ICSE. Many times question is asked about formation of ammonium ion. To explain to you, first let me make the structure of ammonia, which I think we believe in the last class we have discussed ammonia structure. Nitrogen outermost shell 5. Let me make it again 1, 2, 3, 4, 5. Because atomic number is 7, so configuration is 2 and 5. 3 hydrogen. So let me make hydrogen, one hydrogen let me make it here, second hydrogen let me make it here, third hydrogen let me make it here. If you like you can make it on the lower side also. So then one electron around this is what is being shared like this. Now you can see nitrogen 1, 2, 3, 4, 5, 6, 7, 8 octet configuration. Each of the 3 hydrogen is duplet. Then in ammonia we have the structure something like this. Single covalent bond with that hydrogen, single covalent bond with this hydrogen and single covalent bond with this hydrogen. Then you should know this 2 electron of nitrogen was not used in the formation of bond. So that's why we call that as the lone pair. So here lone pair of nitrogen. This lone pair not used in the formation of bond. This is ammonia. Structure ammonia. Now to this ammonia, now our H plus proton is coming to share electron. Now proton comes and tells ammonia, come on friend, let us share electron. Now H plus is coming here to share electron. And yes, please understand that ammonia, the total number of electrons and protons are same. Nitrogen 7 electrons, 7 proton, hydrogen 1 electron, 1 proton, hydrogen 1 electron, 1 proton. That means overall the total number of electrons and proton in ammonia, they are same. So that's why it has no charge. Ammonia has no charge, no charge. But now you will see that later on when ammonium is formed, you know, it will develop a charge. So from where that charge is coming? You can see H plus is coming here. Now H plus means just a proton. There is no electron. It doesn't have any electron. But this H plus comes and says, come on friend, let us share electron. Now it is saying to share electron, but it doesn't have any electron of its own. See, when it so happens, okay, I'll give you the same example. It so happens sometime that during your tiffin, you take your tiffin, your favorite tiffin which your mother had prepared, and your friend will come. Hey, come on friend, let us share our tiffin. Now he'll come to share your tiffin, but as such he will not bring his tiffin. So sharing means he will only take yours, but then he is not ready to give his tiffin. In fact, he doesn't have any tiffin at all. So such kind of sharing is not mutual. So that means the sharing which is taking place here is being contributed only by nitrogen. Now hydrogen doesn't have any electrons, so it has nothing to contribute. So what it does, this H plus will use the lone pair of nitrogen as if it is his own. So again I am repeating, as if it is his own. So here they are sharing. So that means even though there is a sharing of electron between nitrogen and H plus, but sharing is not mutual, because both the electrons are given by nitrogen. But this H plus is getting the duplet configuration because it is getting to use this lone pair as if it is its own. So it is getting the duplet configuration. Now don't forget, overall number of electrons and protons are same, but now one proton is getting added up there. So overall if you take all 4 hydrogen and 1 nitrogen, 1 positive charge is what is coming extra. Now here it is not a mutual, only electrons are being contributed by nitrogen. That is why if I make the structure, now I will make it something like this: nitrogen, hydrogen, hydrogen. Now since both the electrons are contributed by nitrogen to that H plus, here a new kind of bond is what is formed, and this bond is what is coordinate bond. Please note that dashes that we have used is for covalent bond, but the arrow that you see is for dative bond or coordinate bond, because coordinate bonds are dative bond. Now how do I represent an arrow? Who is contributing the lone pair? It is the nitrogen who is contributing the lone pair, so the arrow should be pointing towards the other atoms from the one who is contributing. Nitrogen is contributing, so that's why you have to point the arrow from nitrogen towards hydrogen. And this is what is the formation of your ammonium. Put it inside a bracket like this, a big bracket, and overall now there will be a positive charge. And I already told you why there is a positive charge, because now 1 proton is extra as compared to electron. 1 proton overall is more as compared to electron, because of which ammonium now will get a positive charge. So there it is, NS4 plus 4. How 4? 1, 2, 3, 4 hydrogen, 1 nitrogen, and here 3 of them are covalent bond, 3 single covalent bond, 1 coordinate bond. So this is coordinate bond, so where contribution was, both the contribution was from nitrogen. This is what is the formation of your ammonium ion. Now let us see the formation of hydronium ion. You will come across this hydronium ion plenty in our 3rd chapter, that is acid, base and salt chapter. You know, the very basis of your acid. All acids are acid because of the presence of hydronium ion. Now what is hydronium ion? Let us see. Water. A little while ago I made the structure of water. To water, when the same our H plus is coming and joining, here it was H plus with ammonia, now that is H plus with water, then hydronium ion is produced. Okay, let me now, how I have represented here, same way I will represent there. First let me make the structure of water. I think just now I made it, so here it was like this. A little while ago I told you single bond, and here oxygen now will have two lone pair, one lone pair on the upper side, the other lone pair on the lower side. This is what is the structure of water, with 2 lone pair present in oxygen atom. Now our H plus is coming to combine with water. Okay, here our H plus is coming and says to water, come on friend, let us share electron, but it doesn't have any. So that means the lone pair of oxygen is what is being used by this H plus also as if it is its own. So oxygen configuration is not affected. 2, 3, 4, 5, 6, 7, 8, same. But this 2 electron of oxygen is being shared. Again I am saying sharing, not transfer. It is being shared by H plus. So now H plus is also getting 2 electron, lone pair from oxygen. So then if I represent this in terms of the, here you are, H. So again total number of electrons and protons present in water is equal, same number of electrons and protons present, that is why neutral, no charge, water doesn't have any charge. But 1 proton extra is coming to join there. So since 1 extra proton is coming, so that means now electron deficit will be there. There will be less electron, 1 electron less as compared to proton. So because of which overall charge of your hydronium ion, this is H3O, S3O, 3 H are present, and it doesn't, like a lone pair will remain, one of the lone pair will remain as it is. So one lone pair only was used, the other lone pair will remain as it is. So overall, you know, because of the presence of one extra proton, your hydronium ion is what is produced. Now your syllabus also mentions about formation of OH ion. Okay, now see, OH ion formation is exactly opposite to the formation of these two molecules, two ions rather. So formation of ammonium ion and hydronium ion, how you add H plus. Now in formation of OH minus is just the opposite. Now let us see what is that. In water, if you can remove H plus, from water, then you will get OH minus. See, hydroxyl ion, we call that as hydroxyl ion. Okay, let's take an example again. H dash O dash H. So 2 lone pair. Now here we don't have to do anything with the lone pair. Now what we do? One of the hydrogen is removed. You have to remove. Previously we were adding, now we are removing. Now when this hydrogen is removed, now don't forget this hydrogen has one electron, which it is sharing with oxygen to form a covalent bond. Now when that hydrogen is removed without its electron, now it will leave behind the electron there. If it is leaving behind the electron, now only hydrogen is going out. Now hydrogen is going out means, there it is, hydrogen is going out, H plus, without electron it is going. It left behind his electron here. That means already the total number of electrons and protons present in hydrogen and this oxygen, they were equal, so no charge. But since this hydrogen has gone out without electron, it has taken only the proton, electron is left behind. So because of which now OH is what is left. So here your OH is what is left, and that OH is left with one negative charge, and that negative charge has come from this hydrogen because the hydrogen has left behind his electron. So that is why OH part which is formed will be having one negative charge. This is what is your 3 kind of bonding which is there in your syllabus. Even though in class 11 you will learn about some more different kind of bonding, many other bondings are also there, but till this point I think your class 10 syllabus you have only this many bonding. They were what are the one which we have seen already? Electrovalent bond, also called ionic bond. Second one was ionic bond was transfer of electrons. Covalent bond, sharing of electron, mutual sharing of electron. Then third today what we saw was coordinate bond or dative bond. So it is not mutual, both the electrons are contributed by one single atom, so that is what is a coordinate bond. And also formation of this two takes place because of the formation of coordinate bond. See, ammonium formation also coordinate bond, hydronium also coordinate bond. So both these ions very important from your ICC point of view, from your board point of view. These questions are asked. Write the formation of ammonium ion, hydronium ion. Alright, something which I have left out before, and then in the previous class also I told you that we will discuss this at last. Now I am going to see some properties of electrovalent and covalent compound. Properties. Now I am going to discuss, there are so many properties, but I will restrict myself to only the points which are given in your syllabus. So what are the points? Yeah, you can take this as also the difference between electrovalent and covalent compound. Yeah, if you don't want to learn it as a property, you should also learn it about. So look, let me make a table here and discuss about the differences, and at the same time again I should tell you that this is also the properties of electrovalent and covalent. Look, let me then write down here electrovalent, also called ionic, and this one is covalent. Now, what are the differences or the properties that you are supposed to do? Okay, I am starting with the first. I am going exactly according to what is mentioned in your syllabus. So, the first one is state. State means which state usually you will find. Electrovalent bond, as you saw, that was a very strong force of attraction between the two. When the transfer of electron took place, electrostatic charge, positive charge, negative charge. That is why electrovalent bonds are very strong bond, whereas covalent bonds were sharing of electron. Since sharing of electron, here it was transfer, here it was sharing of electron. So sharing of electron bond which was formed, covalent bond, they were weak bond. Since the bond between these two is very strong, usually electrovalent compounds are hard solids. So that means if you are talking about the state, usually electrovalent compounds are hard solids. Usually, it is not necessarily all 100% of the electrovalent compounds are solid. Yes, there might be some liquids, but then as such, majority of the compounds, electrovalent compounds, are solids. Whereas, because of the fact that the bonding between the two are very weak in covalent as compared to electrovalent, so bonding very weak, they are not held together by a very strong force of attraction, because of which covalent compounds usually are gases or liquids, or in case if you find solid, they are usually very soft solid. So that means if you are comparing about electrovalent, see, but we are discussing two things at a time, difference between the two also, and we are also discussing about the properties. I am in fact taking the properties, but at the same time if you are asked, hey, write the difference between electrovalent and covalent, you can go about this one. Now next one is melting point and boiling point. Okay, since the two atoms are held together by a very strong force of attraction, here very strong force of attraction, positive and negative, they cannot be broken down easily. So you need to heat them to a very high temperature, then only they will melt or they will boil. So that is why we say they have very high melting point or boiling point. Yeah, why? The reason is the same that I said here, because of a very strong force of attraction between the atoms or between the ions. Whereas here the force of attraction between them is very weak, can be easily broken. So that's why they have very low melting point and boiling point. So low melting point and boiling point. Then if I am going on to the third property, then this is with respect to conductivity. Conductivity of electricity or conductivity of heat. Okay, so here I should tell you, whenever electrovalent compound, okay, before I go to difference or properties of conductivity, I think I should tell you a little bit about two terms, in fact I should tell you. Okay, let me take one example of electrovalent. I think the easiest one that we have learned is sodium chloride. Sodium chloride is a molecule, but this molecule can be changed into ions very easily. Two conditions required. Either you add water, because of the polar nature of water, you know, this will form ions, it will break into ions. Or if you don't want to do that, then you can also heat this so much that it will melt, and when it is melting, it will also form ion. So that means sodium chloride will break to give you sodium ion and chloride ion. Here, these very ions are the one which are responsible for conduction. Again, there is a difference between conduction in metal and conduction in chemical compounds. Chemical compounds will conduct electricity when they have ions. When this kind of charged ions are there, mobile ions are there, ions which can move are called mobile ions, then they can conduct electricity. Unlike metallic conduction, in metallic conduction it is electron movement, but here it is ionic movement. You will see this again in chapter electricity, electrolysis. In electrolysis, it is all about this ions only. So when ions are formed, they can conduct. If ions are not formed, they cannot conduct. But again, the condition of conduction is that they might be either in aqueous form, aqueous means when you have added water, or they must be molten, aqueous or molten. Then since ions are formed, whenever electrovalent compounds are breaking into ions, the word that we use is dissociation. So we say electrovalent compound or ionic compound dissociate into ions. When aqueous solution, when they are in aqueous solution, or when they are molten. But covalent compound, they don't conduct electricity, because covalent compounds, you know, they are consisting of, for example, if I am talking about one covalent compound, methane, yeah, covalent compound. Now, no matter what you do, how much you heat, you know, it will not form any ions. No ions are formed. So since no ions are formed, no conduction. But I should again remind you that special covalent compound, which we call polar covalent compound, HCl, polar. Since it is polar, so whenever you dissolve in water or you heat it, then it may break into ions. Yeah, even though it is usually covalent compound don't break into ion, but a polar covalent compound can break into ion and start conducting electricity. So exception is polar covalent compound. Even though generally we say covalent compound, they don't conduct electricity, but polar covalent compound electricity, because of the difference in electronegativity, as we discussed already, and ions will be formed, and because of this ions only they start conducting electricity. Yes, here I have used the word dissociation, because electrovalent compound, whenever they break into ion, we call dissociation. But covalent, what kind of covalent? Polar covalent compound, whenever they break into ion, we use the word ionization. It is very important term. These two terms are very important in your electrolysis chapters which are yet to come. So maybe in the 4th or 5th chapter that you have is electrolysis. Ionization is used for polar covalent compound, whereas dissociation. Now coming back to conductivity, then how do you say conductivity? Electrovalent compounds are conductors of electricity when they are molten or when they are in aqueous solution. Why? Because they form mobile ions. Covalent compounds are bad conductor of electricity. They don't conduct electricity at all because they don't have ions. Then what do they have? They have molecules. Since molecules are present, they don't. Again, a reminder that polar covalent compound is an exception. Polar covalent compound can conduct electricity because even they can form ions. This is what is your property differences between electrovalent and covalent, or the properties between the two. Now next one is, as we discussed already, dissociation. The fourth one your syllabus mentioned is about dissociation and ionization. I think I've already explained to you. So your number 4 is also here. We call this one dissociation. This one is what we call ionization. Polar, that also only polar. Non-polar compound cannot form ions. So the fourth property discussion that we have to do about electrovalent and covalent compound is that, so it can dissociate to form ions, mobile ions. It can not dissociate, it will remain as a molecule only. But polar covalent compound can ionize and then form ions, and even this polar covalent compound conducts. So if you are asked a question, HCl is a covalent compound, then why does it conduct electricity when added to water, or when water is added to it? Then you will simply say that HCl is a special covalent compound. It is polar covalent compound, and whenever water is added, it will ionize. It will ionize to form ions, and as long as ions are formed, mobile ions are formed, it will start conducting electricity. That is why this also is a conductor of electricity. So with this we have completed the chapter. So the difference between electrovalent and covalent, many are there. I think if possible, I'll put it down in the description, one link, PDF file. You can download it and read differences. Here I have discussed it in form of properties. But if you want, you can also take these 4 as the differences between the two. So if you are asked what is the difference, then you can say hard, solid, then they are gases, liquids, and soft solid. Then high melting point, boiling point, they are low melting point, boiling point. Then you can say this will undergo, they are forming ions, they are consisting of ions, and because of which they conduct electricity. They are consisting of molecules, they don't conduct electricity. Then after that you can say that whenever electrovalent compounds break into ions, we call it dissociation, and when polar covalent compound breaks into ion, we call it as ionization. Okay, so do the exercises, the questions which are there in the exercises of your book. I think you people have your books now, so I don't have to put the PDF for the book. You have the book. All objective questions of your book, you will tick mark with the pencil there in the book only. Objective means multiple choice. Many questions are multiple choice question. So in chemistry, most of the question can be done there in the book only. I don't waste your time in writing in your copies. So I want you all to do it in the book itself. Multiple choice questions, fill in the blanks, one word answers, all you fill it there in the book with the pencil. You don't need to do it. But then if there are some questions like where you will not be able to mention it there in the book, not space, your space is not sufficient to write there in the book, then you can use your copy. Okay, with this we have finished the chapter. So now I'll start with the next chapter in the next class. Yeah, thank you and bye bye.